we're going to talk about upper and lower bounds. Upper and lower bounds on a graph are the integers that the first integer to the right or to the left of your last zero. In other words, the graph will never cross the x-axis after those values. So this would be your upper bound, which I abbreviate as UB. And this value, whatever it would be your lower bound, because your graph will continue to go up positively, never to cross the x-axis on the right, and on the left, never to cross the x-axis again after that integer value. So graphically, that's what an upper and lower bound means. Does that make sense? Yes? Okay. So what is an upper bound in words? When using synthetic substitution. So we're using synthetic substitution for these. All the signs that you get are either all positive or all negative. I'll show you what I'm talking about when we go through and actually do one of these problems. Okay? But we will know that we have an upper bound when we do synthetic division and all the values are either all positive or all the values are all negative. Okay? There are no sign changes. The upper bound is it's defined to be the first integer that falls to the right of the zero, the last zero that achieves no sign changes. Okay, the lower bound. So the lower bound, if you found the lower bound, you want it to have the signs that are alternating. So if the first answer that you get when you do synthetic division is positive, the next one's going to be negative, and then positive and negative as we're using synthetic division and creating our coefficients, basically. Okay? So it is the first integer that falls to the left of 0 that achieves alternating sign changes. The graph will not cross the x-axis again to the left of that number. It just continues on. So it will never cross to the left of this value and to the right of that value. Does that make sense? Okay. Anybody have a question so far? So, you know, when we did our P's over our Q's, we came up with our pool of possible positive and negative numbers that are going to work to find our zeros, correct? And then we did Descartes' rule, which said we can determine how many positive and how many negative zeros we're going to have, correct? And so that made our pool even smaller, all right? This is going to tell us, to help us graph, to know that after certain values, we will always either say above the x-axis or below. So I'm wanting you to find an integral upper bound and a lower bound, so I'm just wanting the upper and lower bounds, of 6x cubed minus 7x squared minus 14x plus 15. Okay, we learned from yesterday how to figure out how many possible positive and negative roots there are going to be. How many possible positive ones are there going to be? There's going to be a sign change here and a sign change here, correct? So yes, it will be 2 or 0. So you'll either have 2 possible roots or no possible roots. All right, to figure out our negative ones, we have to use negative x, correct? We have to substitute in and rewrite our polynomial. And so we get negative 6x cubed minus 7x squared plus 14x plus 15. So how many sign changes do I have? Do we agree that there's only one? There's one right here. That implies either 1, there's no 0, right? We can't subtract 2 from 1 without getting a negative value, so we just have 1. All right. So we know that we've got a negative value and we've got 2 positive roots. Okay? All right, so here's what we're going to do first. We're going to start at 0. And we're going to do synthetic division with 0 to see if we've got any sign, what kind of sign changes we've got going on. Okay? All right, at 0, we know that the first thing we always do is bring our 6 down. And then 0 times 6 is 0. And then plus negative 7 is negative 7. 0 times negative 7 is 0, and then we get negative 14. This is how you're going to find your lower and upper bound. Start at 0, you work your way up the negatives and down the positives. until you see the sign changes that you're looking for. Does that make sense? Okay. So 0 times negative 14 is negative 14 plus that. Okay. So notice our signs are alternating positive, negative, but then it doesn't go back to positive, right? They're not all negative. They're not all positive. This is neither an upper or a lower bound. So this is nothing. Okay. All right, let's look at where we can find our lower bound. Let's try at negative 1. So if we want a lower bound, what are we looking for in terms of our signs? So lower bounds have to be alternating signs. Positive, negative, positive, negative. Okay, so negative 1 times 6 is negative 6, and plus negative 7 is negative 13. So far, so good. Negative 1 times negative 13 is 13. Minus 14 is negative 1. It's not going to work, is it? No. Okay, let's try negative 2. 6 times negative 2 is negative 12. Negative 19. 38 minus 14 is what? Negative 44 plus 15 is negative 29. Do you see how our signs are alternating? Starts out positive, the next number is negative. Then we get positive value, then we get negative. That implies that this is a lower bound. In other words, when we're graphing, we will find no zeros to the left of negative 2. Haven't we just kind of made our pool of numbers even smaller? Do you see? Because our P over our Q, our P is 15, our Q is 6, isn't it? So we could have negative 15 as a possible negative root, right? But we just realized at negative 2, we're not going to find anything past negative 2. So we've just made that pool of values even smaller. You follow that? So we don't have to go past negative 2, because we should get all sign changes after that. Okay? All right, so now let's find our upper bound. So let's try 1. For an upper bound, what are we looking for in terms of our sign changes? They're all the same. They're all positive or all negative. And in this case, what are we going to have? If 6 is our first number, they're going to have to all be positive values, okay? So 6 times 1 is 6, plus negative 7 is negative 1. I don't even have to go any further than this, do I? Because I'm not getting strictly positives. Try 2. 6 times 2 is 12. 12 minus 7 is? 2 times 5 is? 10. Oh, we get negative 4. Again, I don't have to go even any further than this. 3. 6 times 3 is 18, and we get 11. No, we don't. Oh, yeah, we do. I want to say 9, yeah. Okay, and 3 times 11 is 33, and 33 minus 14 is? And 3 times 19 is 57, and 57 and 15 is? Is this my upper bound? Sure is. Sure is. Yes? I'm not looking for my zeros. I'm not looking for my zeros. I'm not asking where my graph is crossing the x-axis. I'm saying at what value will I not find any more zeros to the left or to the right? So if I look at my graph, Angela, I know that after negative 2 and after 3, I'm either always up here or down here. In other words, all of my zeros have to fall between these two values. They won't. This is telling me you won't find anything. Well, you'll have to start out at 0 and work your way up and work your way down until you find your sign change. Maybe you have to go to 18, but I'm not going to make you do that. Okay? I think maybe up to 6 or 7 might be the furthest out you have to go. Okay? But we have just limited where our zeros are going to be, haven't we? You all see that? Okay. All right, let's try another one. Find the integral upper and lower bounds of the next one. Okay, how many positive and how many negatives? Well, how many positives are we going to have? Well, it's kind of hard to say because we've got all these zeros, right? Does that make sense? So it's really hard to determine because zero is neither positive or negative. But I guess if we looked at it, we could maybe say that there's one sign change, right? And for the negatives, we would look at x to the fourth plus 4x squared minus 2, correct? And so how many would we have now? 1. So there's 1 here and 1 positive. But the zeros are kind of going to throw you off because zeros are neither positive nor negative. So we're going to start at 0 because we're looking for our upper and a lower bound. So bring down the 1. 1 times 0 is 0. 0, 0, negative 4, negative 2. Zeros, again, are neither positive or negative. So we don't know if we're alternating signs or if we're staying the same. So this gives us no information at 0. Does that make sense? Yeah, it won't be either. It doesn't give us any information. So, all right, let's find our lower bound. 1, negative 1. 1, negative 5, right? 5, 3. What is this? It's our lower bound. Now remember, roots don't have to be integers. They can be decimals, right? To the nearest tenth or the nearest hundredth. Okay. All right, we found our lower bound. Let's try 1. 1 times 1 is 1. 1, 1, negative 3. I'm going to continue this out just to show you something else. Negative 3, negative 5. Okay. It's nothing, correct? 1, 2, 4, 4, 6. There's my upper bound. Are we good? Okay. I want you to get your calculator out. I'm going to let you see something on your calculator. You can check it, all right, but you won't be able to do this on a test. We're going to turn our calculator on. We're going to go to y equals, and we are going to clear out anything that we have in here. And I'm going to have you plug in x to the fourth minus 4x. What is the rest of it? Minus 2, minus 2. And I want you to graph it. So we're really only showing 2 real roots, right? How many roots are possible in this problem? 4. 2 are real. What are the other 2? Does that make sense? Okay. Notice, I want you to kind of zoom in. So we're going to zoom in really close. Where are the zeros occurring? Between which 2 integers? Why would you say negative 1 and 2? Here's negative 1 right here, right? Isn't it crossing in between negative 1 and 0? Where else is it crossing? Here's my y-axis, between 1 and 2. Are you following this? Do you see that on your calculator? Yours is what? You plugged something weird into your calculator then. Okay, come back and look at this chart. Where did we say the zeros were occurring between? Zero and negative 1, and 1 and 2. Did I do something wrong here? Okay, math. Look at your sign change. See your sign change? I'm going from a negative y value to a positive y value, right? Doing substitution. Isn't that going to indicate that we've got some kind of a crossing of the axis? What's wrong with yours, Meg? No, you, what? Claire. Y equals x to the 4th minus, graph it. You have, what do you have your table set at? I think that's right. Your increments are weird though. Zoom out. It's the same shape. I don't know what your x what your x. You had your, let me see, how are you going up by? Your window, oh, well, you're going up by 0.1. Let's try going up just by 1. You had it going up by 0.1. We want to go up by 1. Okay, whenever that happens, go to Zoom Standard, and it fixes everything. Okay? All right, look at your table. See the table right here? Go to second table. Second graph. All right, look at your value at negative 1. What did we get at negative 1? 3. What did we get at 0? See how the graph is changing and crossing the x-axis because it's going from a positive y value to a negative y value. Where else did we say it was supposed to cross? Between 1 and 2. Okay, so your table is showing you where your graph is crossing because the y value is going from a negative y value to a positive y value. Are you with me on this? See? My y value at 1 is negative 5, and at 2 it is at 6. At 0 it's at negative 2, but at negative 1 it's at positive 3. So between which integers is our 0? We'll find our zeros between negative 1 and 0, and there we're showing that here. We're showing between negative 1 and 0. We're going from a positive value to a negative value, right? And we're showing a change also in signs between 1 and 2. So there's a couple things that I'm going to ask you again that's going to limit where your zeros are going to fall. So I won't let you use your calculator to do this, but you can check it on your homework. But looking at your answers, what are your answers doing is going to indicate to us where our graph is crossing the x-axis. When we have a sign change, we know our graph is crossing. Okay? How are we doing? Anybody awake? Okay, we're going to move on then. All right, find an integral upper and lower bound. How many positive and negative complex roots? All right, let's do it. So we're going to start at 0. 1, 0, 1, 0, negative 3. This gives me nothing. 0 is neither positive or negative, but it tells me that my final answer is negative 3, right? So these final answers are what we're going to look at to determine between which integers, consecutive integers, we will find zeros. Meg? We should have on this one. I've just kind of skipped that one right now. But yeah, I mean, just do whatever the... So on a test, I'm going to have you do all of this. This will be one humongous problem. You'll have to tell me how many positives, tell me how many negatives, find your possible roots, tell me what the roots are, show me that it's going to work. It's one huge problem, but it's just knowing all how to do all this stuff, right? Okay, so let's find our lower bound. 1, -1, 2, -2. What do I get here? -1. Not looking too good, is it? How about -2? We get 1, -2. 5, -10, 17. What do you think? Lower bound. And what just happened here? It changes signs. So we're going to find a root between -2 and -1, right? Y'all with me? Okay. We don't have to go any further, do we? If it's the lower bound, we won't find another root anywhere prior to -2. So let's try 1. Now we're looking for our upper bound. 1. 1 times 1 is 1. 1. And we get 2. 1 times 2 is 2. 2. -1. Nope. Let's try 2. 1 times 2 is 2. 4, 5, 10, 20, 17. What did we just find? An upper bound. And we found, again, another sign change going on, which means that we have another root between 1 and 2. Are we good? All right, here we go. Determine between which consecutive integers the real zeros are located. How many possible positives? All right, so this is just what we've been doing, right? Okay, you do this one yourself. Figure this one out yourself. So where are our integers going to be, or our roots? Where our roots fall between -1 and 0, 0 and 1, 1 and 2. Okay, so there's a couple problems that they say, tell me what the roots are going to be to the nearest tenth. And so you have to use your calculator for this one. All right, so let's get our calculator back out. And let's plug this equation in. And this equation is 12x cubed minus 20x squared minus x plus 6. Okay, we forgot to decide. We needed to know how many positive and how many negatives. How many positive ones did you get? 2 or 0. And negative ones? Only 1. Total of 3 possible real roots, right? What is our sign change indicating? How many are we going to find? We're going to find 3 of them. So they're all real. Okay? All right. So let's find our roots. We want to set our table. So go to second window. If I want to go up by the nearest tenth, I've got to change this increment, which is right here. It says table, from 1 to 0.1. Because that's going to tell the computer to go by tenths. Okay? Now, where do we want to look between? Well, we don't need to look any further left than -1, correct? Where is our upper bound or our lower bound? At -1. So where do we want the table to start? Do we want it to start at -4 and go up by tenths? No, we want it to start at -1. And so now we want to look at our table. So this is totally a calculator problem. So go to your table. And here we go. We're going up by tenths. We know that we have to find one between -1 and 0. Well, where do we find our 0 at? At -1/2, right here, because of the fact that we get 0. So we know that a 0 is at when x is equal to -0.5, okay? Which falls between -1 and 0. Great. Okay, let's keep scrolling down. Where else are we going to find one? Well, we said between 0 and 1. So now let's look. Between 0, here's 0, and 1, where is a 0 going to occur between? Oh, yes, you do. And 0.6 and 0.7, right? Do you see why it's between 0.6 and 0.7? Why can we say it's going to occur between 0.6, which is 0.792, and 0.7, which is -0.384? We've got a sign change. We're going from a positive y value to a negative y value. So which one is it closer to? Am I closer to 0.6, or am I going to be close? Where is 0 closer to? 0.6 or 0.7? 0.7, right? Because 0.7, you're going to be off by 0.384, whereas if you chose 0.6, you're going to be off by 0.792. So we have another 0 at approximately x equals, what did we say? 0.7. It was between -1 and 0, right? That gave me the first one at -1/2. Then we said between 0 and 1. Isn't 0.7 falling between 0 and 1? You have to figure out which one is closer, and we're closer to the 0.7 than we are to the 0.6. Okay, now the next one has to fall between 1 and 2. So let's look. Between 1 and 2. Oh, well, guess what it is? 1.5. Didn't we exactly have a 0 at that value? So my last 0 is at 1.5, which falls between 1 and 2. How are we doing on this? So go to your table sets. Go to your table when you've got to set this up, because you've got two problems where they want you to find it to the nearest 10. So you'll see it says approximate the real roots to the nearest 10 is what the directions in the book are.
And what about the 0.4?
The 0.4?
In a table set.
Oh, no. So my table set, I wanted to go, I needed to start, this should have been. I knew that there was no 0 prior to -1 because that was my lower bound. Wasn't it, Angela? Well, that's probably because you were cursing up. It changes as you are cursoring through your chart. Mine was at 1.1, and I know I put -1 in there. That's just going to start your chart at that value. So if you go back to your chart, you're probably at 0.4 or something.